Hello everyone. For today's video, I would like to talk about the summary for Chapter 8, which is Subnetting IP Network Summary. So, Chapter 8 consists of subnetting an IPv4 network, and consisting that is the network segmentation, subnetting an IP, version 4 network, subnetting a by 16 and by 8 prefix, subnetting it to meet requirements, benefits of variable length, subnetting masking, addressing schemes, structure design, design consideration for IP version 6 consisting of subnetting an IP version 6 network, network segmentation, broadcast domain, and broadcast domain. Broadcast domain, an Ethernet local area network devices used to broadcast. Okay. Consists of two other devices and services. Other devices uses an address resolution protocol, or also known as ARP, which sends layer 2 broadcast to a known IP version 6 address on the local network to discover the associated MAC address. The other one is the services. A host typically acquires its IP version 6 address configuration using the Dynamic Host Configuration Protocol, or DHCP, which sends broadcast on the local network to locate a DHCP server. Next one is the problems with large broadcast domains. A large broadcast domain is a network that connects many hosts. A problem with a large broadcast domain is that this host can generate excessive broadcast and negatively affect the network. Connects 400 users that could generate broadcast traffic, resulting in, there are two, slow network operation due to the significant amount of traffic it can cause. Number 2 is slow device operation because a device must accept and process each broadcast packets. And the last one is the reason for subnetting. Reason for subnetting reduces overall network traffic and improves network performance. It also enables an administrator to implement security policies such as which subnets are allowed or not allowed to communicate together. Next one is subnetting an IP version 4 network, consisting of number 1, octet boundaries. Octet boundaries. Every interface on a router is connected to a network. The IP version 4 address and subnet mask configured on a router interface are used to identify the specific broadcast domain. Number 2 is subnetting on the octet boundary. To understand how subnetting on the octet boundary can be useful, the enterprise could further subnet the 10.0.0.0 by 8 address at the octet boundary of by 16. This would provide the enterprise the ability to define up to 256 subnets. For example, 10.0.0.0.0 by 16 to 10.255.2.0.0 by 16, which is subnet capable of connecting 65,534 hosts. Notice how the first two octets identify the network portion of the address, while the last two octets are for host IP addresses. Next one is the classless subnetting. The examples seen so far borrowed host bits from the common by 8 and by 16 and also by 24 network prefixes. However, subnets can borrow bits from any host bit position to create other masks. For instance, 8 by 24 network address is commonly subnetted using longer prefix lengths by borrowing bits from the 4th octet. This provides the administrator with additional flexibility while assigning network addresses to a smaller number and end devices. Next one is the creating two subnets. To see how a by25 subnet is applied in a network, considering if the topology has two LAN segments attached to its gigabit Ethernet interface. Each local area network is assigned one of the subnets. Next is the subnetting formulas. To calculate the number of subnets can be created from the borrowed bits. Use the formula that can be created when borrowing 1, 2, 3, 4, 5, or 6 bits. To calculate the number of hosts can be supported, use the formula displayed. Creating 4 subnets. Now consider the network topology. The enterprise is using the private network address 192.168.1.0 by 24 range and requires 3 subnets. Borrowing a single bit only provides 2 subnets. Therefore, another host must be borrowed using the 2 raised to n formula. For 2 borrowed bits result in 2 raised to 2 is equal to 4 subnets. The specific of 4 subnets, the resulting subnet mask of byte 26 or 2.255.255.255.192 is used by all 4 subnets. Next one is the subnetting a by 16 and by 8 prefix. Creating subnets with a by 16 prefix. In a situation requiring a larger number of subnets in IP version 4, network is required that has more host bits to borrow from. The network address 172.16.00.0 has a default mask of 255.255.0.0 or by 16 prefix. This address has 16 bits in the network portion and 16 bits in the host portion. The 16 bits in the host portion are available to borrow for creating subnets. The table in the figure highlights all the possible scenarios for subnetting a by 16 prefix. Next one is the creating 100 subnets with a by 16 network. Consider a large enterprise that requires at least 100 subnets and has chosen the private address 172.16.0.0 and a prefix of by 16 as its internal network address. When borrowing bits from a by 10 by 16 address, start borrowing bits in the third octet. Going from left to right, borrow a single bit at a time until the number of bits necessary to create 100 subnets are reached. Next one is they calculate the host. To calculate the number of hosts each subnets can support, examine the third and fourth octet. After borrowing 7 bits for subnet, there is host bit diff remaining in the third octet and host bit remaining in the fourth octet for a total of 9 bits that were not borrowed. Next one is the subnetting to meet the requirements, consisting of subnetting based on host requirements. There are 2 considerations when planning subnets. Number 1 is the number of host addresses required for each network. Number 2 is the number of individual subnets needed. Next one is the benefits of variable length subnet masking. Traditional subnetting wastes addresses. Using traditional subnetting, the same number of addresses is located for each subnet. If all the subnets have the same requirements for the number of hosts, this fixed size address block would be efficient. However, most often that is not the case. Next one is the variable length subnet mask. In all of the previous example of subnetting, notice that the same subnet mask was applied for all the subnets. This means that each subnet has the same number of available host addresses. Next one is the basic VLSM. To better understand the VLSM process, go back to the previous example. The network 192.168.20.0 by 24 was subnetted into 8 equal sized subnets. 7 of the 8 subnets were allocated, 4 subnets were used for the LAN, and 3 subnets for the WAN. Connections between the routers. Recall that the wasted address space was in the subnet used for the wide area network connection. Because those subnets require only 2 usable addresses, one for each router interface. To avoid this waste, VLSM can be used for create some smaller subnets for the wide area networks. Next one is the VLSM chart. An addressing chart can be used to identify which block of addresses are available for the use, which ones are already assigned. This method helps to prevent assigning addresses that have already been allocated. So that's all guys for chapter 8, subnetting IP network summary, and see you in chapter 9 summary. Thank you.